I started recording, hopefully it will start soon. And here, so the formal charges to each atom in the following molecules. For carbon monoxide, it is carbon monoxide, carbon and oxygen. The problem is if we would just make two double bond between carbon and oxygen, right? Here it says that why it doesn't move. Oh, it doesn't move. That means anyway. So carbon and oxygen, if we had only double bonds between them, right? First of all, what we have to do is the valence electron, right? Total valence electron for carbon and oxygen, and that is carbon has 4 at the outer shell, that is the valence electron, and oxygen has 6. So it is 4 plus 6 is 10 electrons, isn't it? So see, 10 electrons it has, or both together. So what would be the problem if we just make carbon and oxygen double bond, right? Carbon and oxygen double bond, and the rest, I think I need to show so that I can write. One second. Here, carbon, what is tutorial 4? We got the tutorial 4 here. I think I can write on it. I have some problem with the file. I misplaced it anyway. So, but the answer script is already uploaded, so it will be the same thing, right? Now, if we would just make it 2 double bond, then what would be the problem, right? What would be the problem? It should be no problem, right? Because 10 electrons and then the rest. So 1, 2, 3, 4. Hold on, yeah, I need to have it on PDF so that I can write. Okay. Here. All right, here. So sorry for the glitch. Right. So if we would make it just 2 double bond, because the total valence electron is 10 for this molecule, both of them together, to TVE, actually total valence electron is 10. And so there are 2 electrons here in this bonding. There are 2 electrons here in this bonding, right? So 2 to 4 gone, and then the rest 6 electrons should be put here. And the 2 is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 2 electrons should be here. So in this case, when we are making it 3 double bond between electrons, to make it bold, line, color. Okay, so when we are having 3 triple bond between carbon and oxygen, and this triple bond is taking 6 electrons, so another 4 electrons on the other side. If we want to find out the formal charge and oxidation state is different, okay? I know that we have started the oxidation state and oxidation reaction, but oxidation state and formal charge are different thing. Formal charge is the calculation of the different electrons between them and the tension due to those relation. So that is the formal charge, but oxidation state is the actual thing. It will be based on the actual electron one atom is sharing. We will talk more about it. We will learn more about it later on, but for now, this formal charge is totally different than oxidation state. Is not the same thing. So this formal charge, what will be the formal charge for this carbon and oxygen? For this carbon, formal charge is the total valence electron for carbon is 4, right? Total valence electron was 4, then it is 2. Here the electrons, 2 unpaired electrons are there. Here, unused electron minus there are how many electrons are here? 1, 2, 3. So half of the bonding electrons. That means 6 electrons. Half of 6 is 3. So half of 6 is 3. So it is 3. So 3 minus 2 is 5. Minus 5. 4 minus 5 is minus 1. And for oxygen, it is the same way, 6 minus 2 minus half of the bonding electron. 2 means here are 2 unused, and the half of the bonding electron, that is 3 electrons here. So it will be positive 1, equal to positive 1, and this is positive 1 for oxygen, the formal charge. If it were carbon-carbon double bond just, if it were carbon-carbon just double bond, then what would be the thing here, right? Carbon-carbon double bond, if we would just make, let's see, carbon-carbon double bond, carbon-oxygen double bond. So 4 electrons gone here, 5, 6, 7, 8, 9, 10. Since they cannot take more than, they do not have 2, 4, 6, 8, 9, and 10. All right. So since oxygen and carbon both do not have their d orbital, they cannot have more than 8 electrons. So that is why maximum 8 electrons they can have. See, now you see that carbon and oxygen here is the formal charge on oxygen. What will be the formal charge on oxygen for this oxygen here? It is 6 minus this 4, 1, 2, 3, 4. So 4 minus these 2 electrons. Half of 4 is 2 anyway. So it is 0 for oxygen. For carbon, though, there are 4 carbon has 4 valence electron, minus 2 electrons, right? So in this way, it is also 0. So this structure has less formal charge than this structure, and this is why it will be more stable than this one. It is more stable than this one. And now you can go, this is all chlorine, I don't know, it's broken already. It's nitrogen and chlorine in this way. So for this purpose, if we find out the formal charge for nitrogen and chlorine, we will see that it is 0 actually. This, I don't know from where it comes, because nitrogen has 5 electrons in the outer shell, valence shell, minus it has 2 unpaired electron or unused electron, minus 2, and minus there are 3 bonds, right? 3 bonds with chlorine, each of them with chlorine, and so 3 bonds minus 3 is 5, so it will be 0. So nitrogen is 0, or chlorine as well will be 0, all chlorine will be 0. So in this way, this is 0, I mean formal charge is 0. And for iodine tetrachloride as well, we can find, I mean, we can make this iodine tetrachloride structure in this way. It's Lewis structure. And when you make this iodine with 4 bonds to chlorine, each with chlorine, and that makes 8 electrons, don't be freaked out, or don't be too sure that you have already made up the octet for iodine, because you have to count the total valence electron. These 2 to 4 electrons should be added to iodine, because chlorine does not take, but iodine takes in this case, because iodine is bigger than chlorine, right? Because fluorine, chlorine, bromine, and then iodine. Iodine is much bigger, so it has more d orbitals in it, so it can take more this lone pair. It does not have to fill up only 8 and then done. No, it can have more than that. Same goes for this xenon. Where is xenon? I will take a lot later on about the xenon. For here, this question number 5 is this is actually a structure of thiocyanide. Okay, fulminate ion. Sorry, it's not thiocyanide. It's fulminate ion. And which one is fulminate? No, this is thiocyanide. Fulminate is CNO. All right. So this is carbon dioxide. This is carbon dioxide, and by this way, if we do the formal charge for this molecule, we will see that they are all in this way. When they are oriented, carbon and oxygen, there is formal charge is 0, 0, 0. But this is a possibility, because carbon can form 4 bonds, total 4 bonds. So it can try to make 3 bonds with 1 oxygen, another one is 1 oxygen. So in this way, you will see that it is also total charge is neutral, because this is cancelled out, minus and positive, and that is how it will be neutral charge. Again, even though it's neutral charge, it will try to be as much neutral as possible, and this is not a possible anyway. So sometimes we can okay, there is a Menti question, I'm going there soon. Okay, so this is the formal charge we have to, whenever we do the structure, Lewis structure, the formal charge we have to find out what is the formal charge. And for thiocyanide, CNS, this is thiocyanide, also the same thing. Okay, thiocyanide ion, CNS. and there is a negative charge. So with this negative charge, one electron should be added. The total valence electron 4 for carbon, and nitrogen will have 5, plus sulfur is 6, plus 1 electron, extra electron, it is coming here. All right. So altogether, what is the 10, 16? So 16 electrons. We have to count all the time that there are 16 electrons. It's broken here, but you know this is the nitrogen is here. Okay. So there are 16. We have to always make sure there are 16 electrons around this molecule, and with the atoms attached. And we found out that which one is the minimum charge, or which one is the smallest charge is associated. All these places we see that it is -2 charge, +1, -2, +2. But for this case, here it is -1, 0, 0. So this is the lowest charge. Moreover, nitrogen is more electronegative than all of them. So the negative charge is associated with this electronegative, so that this is more stable this way. Nitrogen compounds are always problematic, as I said before. So for nitrogen dioxide, it will have the resonance, because the structure is actually the same thing, right? The structure are actually the same thing, this one and this one, because just there one oxygen will have 2 more electron, another one will have 2 less electron, but you cannot, in chemical world, this oxygen and this oxygen, there is no difference. All are the same oxygen, same property, same thing. So we cannot always show that this oxygen has 6 electron and this oxygen has 4 electron. We cannot show this way. In fact, this electron will be jumping not through here. Not through here, it will go from there and then it will come from here in this way. So it is actually changing the space, and that is why we show this oxygen, double bond changes. And double bond changes in this way, this is called that resonance is happening. So this carbonate ion, the resonance is occurring, and all of them, although it looks different, that here it is double bond, here it is single bond, and here it is double bond again, but these three are actually the same thing. All right, so this is only if you show only one. If we show only one, this, no, not this one. If I show only this structure and I do not show these two structure, it will be not the correct, or it will be not full. It will be incomplete. We have to show all three possible, and that is why the resonance structure is important to show. Chlorate ion as well, it do the same thing, and chloride ion actually. So, and they will have the resonance structure. These two structure, especially will have the resonance. So the test question says that difference in electronegativity and type. If the electronegativity is, we have to refer to the, we have to refer to the periodic table, the electronegativity chart. If the chart or the electronegativity is less than 0.5, it is a polar bond, or more than 1.9, then it will be a ionic bond. So aluminium and fluorine, I don't have the value with me right now, but probably it will have, depends on their structure, it will be ionic or non-ionic bonding. So I'm changing back to the, no, cannot change, so I cannot write. Okay, so here from the, I just checked, it is ionic bonding, aluminium and fluorine. Aluminium fluoride is ionic bonding because the difference is 2.5, and so on. Based on their above pairs atom the bond polarity. If we want to arrange the bond polarity, all this thing based on their electronegativity, we will have to find which one is more ionic or more covalent, and this way. And we have to write at the bottom that this is arranged the above pair of atoms in the increasing order of bond polarity. So its polarity is given, right? It says the bond polarity where the polarity is increasing. Okay, where the polarity is increasing. So polarity is increasing from here. It will be ionic bonding. This is the difference is more here. This is 2.5, the difference 2.5, and the another one is 1.3. This is 1.3 actually type of bonding and the electronegativity difference, and this is 1.2. So since this is the highest, is ionic bonding, and this is the lowest, fluorine tribromide, right? Fluorine bromide. So it is going from this side to this side. So fluorine bromide, and then it is less than aluminium bromine. Aluminium bromine is less than aluminium fluorine. So in this way we can show, or aluminium fluorine is more than aluminium bromine, which is more than aluminium fluorine bromide, fluorobromide. So in this way you can show. So the same thing goes here. I'm not going to show all these things. And now it says that total number of valence electrons. We have to find what is the total number of valence electrons. Phosphorus plus 3 of the fluorine is here. So altogether, if we search from the periodic table and see which group of them, we know that fluorine is phosphorus is from 6. Right, so there are phosphorus is from 5. Yeah, phosphorus is 5 group, so it is 5 plus 3 times 7, right? Fluorine has 7 times 3, so altogether 26 electrons are there, and this is the correct formula for chlorine tetrafluoride ion. And chlorine has 7 plus fluorine has 7 as well, times 7, 4 times 7 plus, because of this one extra charge, it will be 1, and all together it should be 36. Yeah, it should be 36 electrons, and we can, chlorine is less electronegative among these, so we can put 4 fluorine. Actually we should put 4 fluorine and then make up the octet for fluorine as well. I am just showing only 1. So 2, 4 and 6, right? And this 2 electron 8. So what is the difference? What is the problem? And then there is one problem here that we can encounter. There are a number of electrons. It should be 32 electrons. What is the problem here? Because of this 4 fluorine, every one of them are having octet filled up, right? every one of them are having octet filled up, so that 8 times 4, and by this way chlorine is having all octet filled up as well. That means chlorine has 8 electrons as well. So that means there are 82 for 32 electrons, right? 32 electrons are there, isn't it? 32 electrons are there, but the problem is that it says it is a negative charge and it has 36 electrons, because chlorine is also from the same group 7A, so it should have 7 electrons, valence electron, and 4 fluorine has 7 electrons each, and 1 electron extra for 1, it is 36 electrons. So what can I do now? It says it's 32, and what should we do? Anyone? Here what we can do is, since there are 4 extra electron, we just put on chlorine, because fluorine cannot extend its octet. It does not have d orbital, but chlorine has, so that the another 4 electron I put it on chlorine, and then I put the negative charge here. Same thing goes for sulfur trifluoride, right? Okay, so these all are given. So if this type of question on the exam and you are given, you say that find the formal charge on what the hydrogen and carbon or nitrogen or sulfur or whatever, and if these all are identical, what you have to do is, or the resonance structure is shown here, what you will have to do is you have to put A and B, right? A and B all the same. If you put B here, this oxygen, you should put B here as well, not A. This oxygen and this oxygen and this oxygen should be same denotation, so it will be A as well, and this is B, because there are different on the oxygens are many oxygen, more than one, so top and right also you can put in that way. So and then you have to find out the formal charge on this oxygen. So if you do not put A and B, or do not denote where it is, and you just say the formal charge of oxygen is 0 or formal charge of oxygen is 1, you will not get marks, because you did not denote which oxygen has the formal charge of 0 or 1. All right. So this is one thing that you please take note. The same thing goes for dinitrogen oxide. This is nitrous oxide as well. So which one is happening? What is the formal charge, and which one of them are more plausible, more possible to stay, depends on the formal charge. So this is basically more about these formal charges. And dinitrogen oxide, it says that which one is the more plausible structure. Explain your answer. You have to answer that this structure is better, or this structure, this is the good thing about the structure, and this is the things that the structure will do, or there's charges, formal charges for this structure has less or more close to 0, or the negative charge is on the less electronegative, more electronegative atoms, something that. So this will be your explanation. All right, not just okay, this is the structure B or structure A is more stable. You don't write like that. Explain. When you say explain and there are 2 marks, so there will be explanation. 2 marks will be on the explanation, not just structure number A or structure number B. You will not get marks if you just do the structure number A, structure number B that way. Okay. So this is one thing. And now wait a bit. I'm going to the Menti question. If I think I prepared one. I still have it or not. Okay, I think it's so easy for you. Anyway, but I'm still, since I prepared it, I still show it. Please go to the Menti, menti.com and then use this code. Why it is like 92436687. Okay, 92436687 and give your answer. Okay. Which one do you think is more plausible? Faster. Give the answer faster. Oh. Faster, only 6 of us. I put 1 minute now. So it's around the same time of your quiz, around 2 minutes. Isn't it enough time? Enough. Enough, enough. See, you just need to do the formal charge, which one? No, I cannot say now before finish. I show you the Menti question now. 3 seconds done. Okay, how many of you have? Only 13. Anyway, at least something. So many students, I mean, many of us choose A, some of choose B, C, and this is a nice trend. Actually, it looks like a good, nice bar chart, but it would be nice if you had answered B, because why it is like this? Okay, B, because you see once again that because of the nitrogen compound you are tricked, all right, and you have to find the formal charge for this. For A, the formal charge on structure A is 5 minus 4 minus 2, right? So positive 1 here And then for this nitrogen is 5 minus 0. I don't know how to write. I cannot write it here. So for the middle nitrogen, the middle one, 5 minus 0 minus 4. So it is positive 1 as well. And the left one was what? Just now we did. 5 minus 4 minus 2 is negative 1, right? So negative 1, positive 1, and then 0. So this is negative 1, the left one on A. This is positive 1 in the middle, and oxygen is 0. But for B, if we see that this nitrogen is 5 minus 2 minus 3 is 0. The right one is 5 minus 0 minus 4 is positive 1, and oxygen is negative 1. So for the, and this is not true as well. I don't know what, I didn't do it, but for A we see that the positive and negative both stay on the nitrogen, whereas oxygen is more electronegative. So oxygen will not let it happen, right? So oxygen will take the negative charge, and that's why B is more plausible, because the negative charge, formal charge for B is on oxygen, right? So that is why the B is more plausible, right? Okay, so those who answered B is congratulations. Those who answered another A or C, I hope that you know now. Okay, so now, do you have any question now? Any question, anyone? Before we move to other section now? So many things to do, and it is no question, yeah? Okay, so what I'll do is I will write something here. That's why I'm taking this white page. I'll talk about the hybridization again. But before that, I can have maybe 5 minutes. Okay, I'll come back after 5 minutes. If you have any question, anyone, you can bring up now, or we can have a chit chat. All right, then you guys take a break. Maybe you can have some tea, coffee, anything you like, and then we come back after 5 minutes.